Welcome to section 9.2. We're going to be doing today both 9.2 and 9.3. And so I'm going to start with 9.2. 9.2 is arithmetic sequences and sums. Now this is a review section from Algebra 2. And so I'm going to go through it as if I expect that you kind of already know a lot of this stuff, but I will again go through formulas and show you things like we did in Algebra 2. So take a look. We give you an arithmetic sequence, and what it says is that the first term is 5, the second term is 8, the third term is 11, the fourth term is 14, and so on and so on and so on. And we want to talk about how do we know it's arithmetic. And arithmetic basically is saying you're continually doing the same thing over and over again. Now take a look. If I let this continue, so we have this is the fifth term. Fourth term is 14. The fifth term is 17. The sixth term is 20. So how do I find the seventh term? Well, what's happening each time? It looks like here I'm adding 3, I'm adding 3, I'm adding 3, so on and so forth. So how do I get the seventh term? Well, the seventh term takes 20 plus 3, so 23. The eighth term takes 23 plus 3, so 26. Okay? Well, how do I find the 20th term? Here's the problem. I don't want to have to keep adding 3 all the way until I get to the 20th term, right? So I'm actually going to move down to this a sub n and get a rule first. Now here's what it's saying. If I look at this sequence, and a sequence just means a list of numbers, then what I'm seeing is that I start with 5, and I add 3 to get to the next term. And what we're going to do is put that in terms of words. And so that's how the nth term works. The nth term says you start with 5, and you add 3 for every next term. It means you have to exclude the first one. And so the way we say next term is n minus 1. And so here's our rule. We call this a rule for an arithmetic sequence, which means a rule to find my list of numbers. Okay, so let's go back to the 20th term. How do I find the 20th term? Well, 5 plus 3 times 20 minus 1 basically means take 5 plus 3 times 19. And what you end up getting then is 62. And so the 20th term would be 62. It's way easier to use this rule than it is to continually add and add and add and add and add every single time. So as we look at, we say a list of numbers or a sequence is arithmetic when you have a constant difference is the word we use it. Okay, now what does it mean? Basically, you add or subtract the same number each time. So our general rule looks like this. A sub n is the first term plus our difference times n minus 1. And this is the general rule, and that should seem pretty familiar to you because we used it in Algebra 2. But again, kind of look at it, know what each thing means. Now, in the first example, I gave you the rule. Really nice of me. Write out the first 5 terms. Well, if I want the first term, can't I just see it's negative 4? If I want the next term, what's this saying? It's saying I add 2 each time. So if I add 2 to this, I get negative 2. If I add 2 to this, I get 0. If I add 2 to this, I get 2. If I add 2 to this, I get 4. Now the problem is I need a rule because I don't want to do this to get the 100th term. So if I'm finding the 100th term, then I take negative 4 plus 2 times 100 minus 1, or negative 4 plus 2 times 99. If I do that, I get 194 is the 100th term. Okay? So taking a look at this so far, I hope this kind of strikes some sort of memory in your brain as to what we've done before. But this is the idea, is that we're using what we call an arithmetic sequence. Now, what I would do, if I were you, is is make sure that you got this somewhere highlighted, circled, starred, whatever, because that's one of the equations that you're going to have to know. Now let's talk about the next example. Suppose we give you the 4th term and a 12th term. Okay, now I'm going to take you a slightly different method than I did in Algebra 2, but we're going to do the same type of thing. Okay, and I'm going to take you the way your book does in case you need to look back and go at it that way. First thing we're going to do is we're going to find the difference of our terms. Okay? And what that says is I have the 12th term minus the 4th term, so I have 8 terms. And because there's a difference, this difference is going to be our n minus 1 portion because we're talking about terms. So when I look at my equation, the second thing I'm going to do is set up an equation. I'm going to try to walk you through this process. Now as we look at this, I'm going to start and say, in order to get the 12th term, I could start with the 4th term and add the difference 8 different times, because there's 8 differences between them. And if I do this, then my goal is I should be able to find what my difference is. So I'm going to plug in the numbers. 48 is the 12th term, equals 8 is the 4th term, plus I'm going to write this as 8d because I always like my number first. If I subtract 8, 40 equals 8d. And if I divide by 8, my difference then is 5. And what's that saying is that every time I go from one term to the next, I'm adding 5. Well, now the question is, can I find the first term? Well, sure. If I find the first term, pick any term you want. I don't care. I'm going to go with the 4th term because it's smaller numbers. What I know is that the 4th term is the first term plus 8 times 4 minus 1, because 4 is the term I'm working on. Okay? So the 4th term is 8 equals the first term plus, what, 8 times 3. I'm sorry, not 8. What am I doing there? The difference we said is 5. I'm sorry, let's plug in this correctly. If I look at 5 times 3, I get 15, and I subtract 15 on both sides. The first term then is negative 7. Now, what I can do is now use what I know to find the 25th term. What I would suggest for you is you write a rule and then find the 25th term. So my rule is a sub n equals negative 7 plus 5 times n minus 1. And so the 25th term, and you can kind of putting a lot in this little box, but so the 25th term is negative 7 plus 5 times 24, just to save myself some space, and I end up getting 113. The whole point was to find 113. Now, boy, did it take us a little bit to get there, but truthfully, I would like to see your rule, because I care about your rule way more than I care about a term. And the idea is, can you find this? Now, if this doesn't make sense to you, again, I have another method that I can show you in class, which was the Algebra 2 way of using elimination. I can show you that in class, but this is the idea. Can we save ourselves maybe a little bit of work? In the end, this does. Okay, so this is the idea of an arithmetic sequence where you're trying to find a rule to find specific terms. What we're going to talk about next is series. So as I slide this down, okay, an arithmetic sequence means that I'm adding up, I'm taking the sum of an arithmetic sequence. We call it an arithmetic series. Okay, and a series is basically when you're just adding up the sums. Now, as I look at this, let me look at the first one. My sequence, my first term is 1, and to get it to each next term, my difference is 1 as well. In an arithmetic series, I'm going to take those and I'm going to add them up. Okay, so the sum of the first term, well, you don't really have a sum, it's just the first term, is just term number 1. This has the sum of 2 terms, so you add up the first and the second term. 1 plus 2 gives you 3. The sum of the 3 terms adds up 1, 2, and 3. The sum of the 4th terms adds up terms 1, 2, 3, and 4. These are called partial sums. And partial sums means you're adding up a specific number of terms. So if I need to find the 5th partial sum, the sum of the first 5 terms, I take 1 plus 2 plus 3 plus 4 plus 5, and I end up getting 15. If I want to find the 100th partial sum, this is basically saying, take 1 plus 2 plus 3 plus 4 all the way until I get to 99 and 100. The problem is, I'm so not interested in doing this. Now, there's a story that goes along with this, which is why it's on your paper. There was a huge mathematician that was asked, who created a problem, and we were told in 2nd grade he created this problem. And he was one of those trouble kids that always would find a way to irritate the teacher. Well, the teacher finally said, listen boy, I'm done with you. To keep him busy, she asked that he add up the first 100 numbers, thinking it would take him some time. Now, the guy that did with this was Gauss. And we've talked about Gauss before. He's the guy that did Gaussian elimination and everything else. And so the teacher said, you're a little punk, so add up the numbers 1 through 100, thinking he'd be quiet. The problem is Gauss did it in 2 minutes. Okay? And he was able to figure out a formula to be able to add the terms together. And the formula goes like this. The sum of n terms is n over 2. Okay, so how many terms there are divided by 2 times the first term plus the last term. Okay, first term and the last term. And he was able to, in a few moments, decide this formula, which is why he's brilliant and which is why he's done all this stuff for mathematics. So let's talk about the 100th term. Because this, again, is a formula you'll need to know. So let's highlight this one as well. Excuse me. Now, take a look. As we do this, let's do the sum of 100. I take 100 divided by 2. My first term is 1. My last term in this case is 100. Now, normally it's not this easy, but we'll show you how to work it if it's not. So 50 is what it's saying. 50 times 101, you end up getting a sum of 5,050. Now, most of the time we're not adding up the numbers 1 through 100. We're adding up some sort of series that maybe goes up by 5 or goes down by 7 or, you know, something a little bit more different. But this is, again, the second formula that you want to know. Okay? Let me show you one more so that you get the idea of the sum without it being so easy. For Mr. Wilcox, of course, he's talking about rally races. The fastest 15 drivers will win cash prizes. First place gets 1,200. Guess what this is? A sub 1. Second place gets 1,150. That's A sub 2. Third place gets 1,100. That's A sub 3, and so on and so forth. What's the total amount of prize money? Now, we're talking about 15 drivers, so we're going to take the sum of the 15 drivers and figure out how much money this place is giving out. As I start my formula, we do 15 divided by 2. First place got 1,200. So this is first place. As I talk about my formula, though, last place is really 15th place. The question is, though, I don't know how much money 15th place got. And so what I need to do is a little bit of work. I'm going to go back to the formula we used above for the sequence to find the 15th term. Now we know the first term was 1,200, and as I look at my terms, what I can see is that I'm going down $50 each time. So it's minus 50 for each place after that. So times 15 minus 1. What you end up finding is that you get, my answer key is wrong, give me 1 second. So 1,200 minus 50 times 14, last place gets $500. Because they're going down $50 each, right? Okay, so my $500 goes in here. What I'm really doing, okay, as I put this in my calculator, 15 divided by 2 times 1,200 plus 500, you get $12,750. $12,000, almost $13,000 is what this company or this place is putting out for the prize money. Okay, and so this is the idea. Most of the time when you're doing a sum, you will also have to use the sequence formula to be able to find the last place. So just kind of be aware of that as you're going through. Now that's the idea of arithmetic, which is 9-2, and we did this in one day in Algebra 2. We're going to do it in half a day, right? Let me show you the other type, which is geometric. So if you flip to the back side, we're talking about 9-3. All right, taking a look at this, geometric. We know that arithmetic means you add or subtract a number as you're going from one term to the next. Geometric means that you multiply. And if you take a look at this first sequence, I think you can kind of see that. Okay, as you look, 3 times 2 makes 6. Times 2 makes 12, times 2 makes 24, times 2 makes 48, and so on and so forth. So what do we know? You start here with 3, and multiply by 2 for each next term. Okay, and I just wanted it in words. If you feel like you don't need it in words, that's fine. Now, how do you find the 7th term? Well, if I take 96, which is the 6th term, and then use G and multiply it by 2, the 7th term is 196. If you multiply that by 2 to get the 8th term, you get 384. Now again, I'm going to skip the 20th term until I know a nice rule. The rule for geometric, okay, G sub n equals G sub 1, which is the first term, times whatever your ratio is, and your ratio means whatever you multiply by each time, to the n minus 1. This is your general formula. I'm going to take my highlighter and make sure we highlight this again. Okay, so how do I find the 20th term? The 20th term says, well, my first term is 3, and I'm multiplying by 2 to the 20 minus 1 exponent. You will get big numbers in this section, and that's perfectly fine. 1,572,864. Again, you're dealing with multiplication, so you should get big numbers. Okay? If a sequence is geometric, then it has what we call a common ratio. In order to find the ratio, you basically divide second term by first, or third term by second, or fourth term by third. You're dividing your terms if you can't automatically look at your sequence and determine what you multiply by. Okay? So what I would like you to do is to find these on your own. Now that we've given you the general formula, and in fact we give you a formula here, I don't think it should be that big of a deal, but take a second and see what you can find. Okay, The next one is the one I want to spend some time in, because the next one, again, we give you two different terms, and I'm going to take you a slightly different way than we did in Algebra 2. If you look at it and you say, Mr. Panic, I have no idea what you're talking about, when we get to class, I'll show you another method to do it as well, okay? Now, we're going to take the same process we did before. We're first going to find the difference in the terms, okay? And so they tell us the 10th term and the 4th term. So 10 minus 4 is 6. And again, this 6 is going to be my n minus 1 because we're talking about our difference in term. And because we're dealing with terms, it goes in the term portion of our equation. Okay, once we find the difference in terms, we're going to write an equation. Let's see if I can write. Okay, we always start with the bigger term. The bigger term, the 10th term, equals the 4th term times my ratio, and because the difference in terms is 6, I'm going to raise it to the 6th power. Now my goal is to be able to find the r. So I'm going to plug in what I know. My 10th term is 125 over 64. My 4th term is 125, and then I have r to the 6th. Now, because I already have a fraction listed, instead of dividing by 125, I'm going to multiply by 1 over 125. So I'm going to times this by 1 over 125. These will cancel, and if you notice, these will cancel as well. So 1 out of 64 equals r to the 6th. And how do you get rid of a 6th power? Use 6th root both sides. And if I take the 6th root of 1 over 64, I get 1/2 is my ratio. Now, after we find our ratio, the third thing we have to do is find our first term. Pick a term that you want. For me, I'm going to stay away from the fractions. I'm going to pick the 4th term. And what I know is that the 4th term equals the first term times my ratio, which is 1/2, to the 4 minus 1, because we're talking about the 4th term. So 125 equals the first term times 1/2 to the 3rd. 1/2 to the 3rd is 1/8. And so what I'm going to do is multiply both sides by 8 to cancel these out. So my first term then is big. It's 1,000. Okay? Now, most important to me is the rule. So what is the rule for the nth term? In this case, the nth term is 1,000 times 1/2 to the n minus 1. And last but not least, they ask you, can you find the 14th term? So I plug in a sub 14 is 1,000 times 1/2 to the 14 minus 1, or the 13th. Hit math fraction when you're done. You get 125 over 1,024. Didn't want to make a circle for me. Okay? So again, I'm trying to walk you through the process every time. If you can find the difference in terms, then write an equation with the two terms, then find the first term, then write a rule, use your rule to find a sequence, or an equation, okay? This is kind of, again, the idea. If this doesn't click with you, again, you want to try some of these on the homework. If it doesn't click with you, I can show you a different way. It's just way more work than this one, okay? All right, let's keep going. Okay, the last thing we're talking about, we found a geometric sequence. Now we're going to add it up again. And like in an arithmetic, when you add things up, it's called a geometric series, which means, again, you're taking a sum. If I look at this first sequence, the first term is 3. And what happens each time? We said we were multiplying by 2. Again, we want to look at definitions. If I say the sum of 1, it just means give me the first term. Sum of 2 means add up the first two terms. Sum of 3, again, we call this partial sums. Doesn't matter if they're arithmetic or geometric, partial sums are partial sums. We're asking you to add up a specific number of things. So if I want the sum of 5, what I do is take my first 5 terms, so 3 plus 6 plus 12 plus 24, and then plus 48. If I add up those first 5 terms, I end up getting 93. To find specific numbers of sums, it's not too bad when it's like less than 10. Anytime it gets higher than 10, it's just a pain without a formula. So, nice enough as we are, we give you a formula. The sum for a specific number of terms is the first term times 1 minus r to the n, all over 1 minus r. I'm going to stick that in parentheses so we don't forget. So, let's go up and use that for the 20th term. The sum of 20 terms, my first term is 3, times 1 minus, my ratio we said was 2 to the 20th, because that's how many terms we're adding up, over 1 minus 2. What I might suggest to you is you do the top first. You get negative 3,145,725. All over bottom is negative 1. So 3,145,725. Again, this equation should seem familiar to you as well because we did that. The last one is what we call an infinite. You'll see an infinity sign in that, but the sum of an infinite number of terms is the first term times 1 minus r. And we'll be looking at specific uses for that as we go through tomorrow, but I at least want to give you the formulas so you've got them. So, okay, in 2 sections, we've just given you 5 formulas. You want to talk about a section for flashcards? This is it, okay? So that's it for 9.2 and 9.3. We'll work on those in class tomorrow.